This is your instructor Ashish. I am making this video for the chapter 1 that we'll be covering in the second week of our online CSC 1613 Java 1 course. So let me go to the modules area, and you can see that we have the start here course introduction and the week 1 where you are going to install the Eclipse software and also participate in the self introduction. I've already covered the information about week 1 in my introductory video, so let me jump over to week 2. The week 2 is where we are starting the chapter 1, and you can see the snapshot that you need to study the chapter 1 and take the quiz on the chapter 1. So let's get to it. We are going to learn about the chapter 1, which is going to introduce you to the fundamentals of programming. I have the ebook with me. Here is the ebook. This is the book we are using, and we will be going through the chapter 1. So I'm going to move to introduction to computers, the internet, and Java. In this chapter, we'll be covering the fundamentals. So we are not going to actually do any coding, and you're just going to learn about from like 100,000 feet view all the way going down to the nitty gritties of Java. So let's get started. Here is the outline, which I will skip. I'm going to the introduction. So computer, is everywhere. There are primarily two things that you have within a computer: software, which is not tangible. We can't touch and feel it, and the hardware, which is tangible, something like a monitor and a keyboard and the a web camera and so on and so forth. So the software, the intangible, actually controls the hardware and performs things. We are going to learn about Java in this semester, which is an object-oriented programming language. And nowadays you have, different kinds of devices and stuff which are built using this programming language Java. As you can see here, there are so many things that can be built with Java, not only just some games or business applications, but many things can be built using Java. Java comes in different formats. You have the Java Standard Edition, which is used for basic level programming, and you have the Java Enterprise Edition, which is used mainly for enterprise level programming. That is, you're writing code for an organization where it will be used by multiple individuals. So you can use the Java Standard Edition for our work, and as you get more into the advanced level Java classes, you may need to use Java Enterprise Edition. There is also Java Micro Edition for devices that do not have a lot of computing power, such as smartphones and you know other such devices of the nature. Going continuing on to hardware and software, let's go to the next area. So we'll click down and move to hardware and software. As I mentioned briefly, hardware is something which is tangible, and software which is not tangible. This is something that you write and gets stored on our computer's hard disk or a USB drive or on a cloud somewhere and things like that. So Moore's law is about the computing power, and Gordon Moore, actually in 1963, who was the co-founder of Intel, said that the computing power of the computers will double every 2 years, and that's what we have seen. So often you will hear that Intel has created a more powerful chip, or the computing power is increased, and so on and so forth. So this is just one of the concepts that you may hear quite a bit. How is a computer organized? You have the input unit that allows us to send information. Nowadays, you have the Alexa and the Siri and all that, where you are using the voice to give the input. Otherwise, in traditional, you have a keyboard. The output device is maybe a screen. It could be your GPS. It could be a phone where you're tapping and you get the response back on the screen itself. You have the memory unit, which is what also called as random access memory. This is where the programs execute, whether it is a Mac or Windows or what have you. Everything that is executing, that is running on your memory. So if you have very limited amount of memory, you may see a little slow behavior when you're using a particular application or doing anything for that matter. Every computer has arithmetic and logic unit. This is responsible for addition, subtraction, multiplication, division, those kinds of operations which are very common in terms of computers usage that we do. ALU plays a very key important part. The CPU is what does the processing, what takes the information and does the processing to compute the output. Nowadays, we have multi-core CPUs, processors, excuse me, where we have multiple processors built inside a single integrated chip. And then you have the secondary storage unit, which is more like a persisting of data. So, in simple words, if I describe it, this is your hard disk. The hard disk within your computer is also called secondary storage unit. It could be your USB drive. It could also be that you are connecting your computer to a Google Drive and saving all the information on the Google Drive. So that there you have it. The data hierarchy, how the data is stored, whether it is the memory or whether it is your hard disk. You have a file. A file may have multiple records. A record may have field, as you can see here, and the field has individual characters, which are represented with Unicode, and these characters are actually made up of bits. So this is the hierarchy. It starts with bits, which can be 0 or 1, and then characters and fields, records and file. Database is nothing but a collection of files, and big data that we talk about a lot these days is uh, the mass of data is very big, and the it's also considered like the velocity of the data. It's growing quickly. It's not structured, such as the comments made on Facebook, or the comments people make on YouTube videos or Twitter. They are very random. So that's what we call big data. And discovering value out of big data is a big deal in today's world, because there is too much information out there, and we need to mine the big data to find the relevant information. This is how we measure the amount of space that we have, from kilobyte to megabyte to gigabyte, terabyte, petabyte, exabyte, and zettabyte. Um, Machine language, assembly language, and high level languages. These are the three languages that have evolved over many, many, many years. Machine language is something that the machine understands. It's a combination of zeros and ones. It is not something that can be used to do complex programming. Assembly language and assemblers is how it was a pseudo programming, whereby you're not writing coding in a very clear instructions. So there's like something is clear and something is not clear, and you would use assemblers to translate these code into machine language at the computer runtime. And then you have the high level languages, which is what we do right now in today's age, whether it is Java, C++, VB, or C Sharp, or what have you. These are high level languages. That is, we are writing the code in English sentences. Most of them are something that we can read and understand. And then we use compilers, interpreters to interpret the code, change it into eventually the zeros and one, the language that the computer understands and the ALU and the CPU understand, and process them at lightning fast speed. But when we are writing the code, we are writing in high level languages. So please remember, machine language, assembly level language, and high level language. So what's an object technology? What is an object? Um, Remember, in a very simple words, Java is an object-oriented programming. All the latest high-level languages that you may come across now are all object-oriented programming. And when you need to think of what is an object, you should think of, hey, the noun, the person, place, thing, or an object, or an object. So think about a noun. Think about automobile as an object. So if an automobile is an object, there are two characteristics about an object or an automobile. It has some properties and it has some attributes. That means we can say the car runs fast, and then we can say the car has a blue color, and car has four wheels, and car has a steering wheel, and it has a CD player. These are the attributes. These are the characteristics, and the car does something such as driving and accelerating and deaccelerating and launching the airbags when the situation demands. So that's what we can consider an automobile and relate it to an object concept. Performing a task in a program is called a method. So method is an important thing. You'll be writing method in the coming weeks. And a class is nothing but the noun. Uh, an object is an instance of a class. A class is something that you will write, and I will show you shortly as well. When you run your code, it creates an instance of that class, and that's what we call an object. Uh, at this juncture, I don't want to get too much into it because I just want to keep it high level since we are in chapter one. Reuse, just like an automobile. When you're creating an automobile, you may build a drawing, and that the engineering drawing, those blueprints can be used to build different kinds of cars, or again make the same car new every year, perhaps. So similarly, we can reuse the code that we write using the object-oriented methodology. The messages and the method calls, we accomplish things by calling methods, and that's what we call them as method calls. The attributes and instance variable, just like I was telling you about, a car can have what is the color, what's the number of doors, and the amount of gas. These are the properties about the car, and that's what in programming language we call attributes. There is a very big concept in programming, object-oriented programming, called encapsulation, inheritance, and another one called polymorphism, which we will come across later. But encapsulation is basically you are all the activity that is required for acceleration is within the acceleration method, and we encapsulate that. That is what it is. If there is the car does the removal of the moon light or the moon door, it might be within that its own method. So if the car has a reverse mechanism, the implementation of how the reversing of the car happens will be in a method called reverse, and we will encapsulate that. We won't hodgepodge and mix and match things here and there. Inheritance is you can have a class that inherits or adopt information from another class. You might have a car as a class, and you might have a sports car, which is very much a car, but it has slightly different behavior than just a normal car. You might have another subclass by virtue of the concept inheritance, where you may have a hybrid car which has everything same as car, but it has other ways of doing things than just a normal car. So this is what we have. um, the concept inheritance is tells you create a class which tells what to do but does not say how to do it. So you create a inheritance in Java called car, and then you will have a hybrid car, a sports car, where the car has a method called acceleration, but the way the acceleration happens will be one way in sports car and another way in the hybrid car. A class that implements zero or more interfaces, each of which can have one or more methods, just as a car implements separate interface for basic driving functions, controlling the radio, controlling the heating and AC, and the likes. What is object-oriented analysis and design? When you're writing a project, when you're working on a project, you need to do this process called analysis, and then you need to do this what's called design. So for the programs you'll be writing in this course, they are very fundamental because this is a beginning level Java course, and you will not have many a difficult time trying to think of, oh, what should be my class here. But the object oriented analysis is about, rather than writing the code immediately, you should think back, try to look at what is given in the assignment or what is given in your project requirements, or what do you plan to do, and think about what are the objects that I can think of. If I'm writing an application to um, build a hospital database, I should think of all the objects that comes to mind. Hospital is an object, patient is an object, physician is an object, appointment is an object, because those are the classes that I can envision and have a mixture of them to build this system called hospital management system. When you are building an application in object-oriented mechanism, object-oriented programming, you do the analysis and then you do the design. UML is a way of depicting visually your design. It stands for Unified Modeling Language. It was created by IBM, but now it is open source. You may go through chapter 11 to look at some of the examples, and also chapter 3 and 4. What's an operating system? We are dwelling down a little bit into more towards the Java. So operating system is nothing but the core software that comes with our computer to do all the work that it's responsible for. And we have different flavors of operating systems, so to speak. We have Windows operating system that we are no stranger to. It has evolved over many, many years, and now we are at Windows 10. We have Linux operating system, which is an open source operating system, one of the most popular operating system used by companies to execute their servers. We have Mac operating system for the handheld as well as the computers that Apple creates. We have Google Android. Obviously, everybody's familiar with Google Android being a operating system for mobile devices. The programming languages have evolved over the many years. Computers are around from different machine languages to assembly languages to high level languages, and within the high level also there were structured programming language, and now we have object oriented programming language. Here you have alphabetical listing of all the different programming language and a small verbiage about what they do. Java is what we'll be learning in this particular course. It was created probably in 1991 by Mr. James Gosling. um, Java inherits quite a bit of information from C++. So if you have taken C++ class, you will see similarities. And if you have taken Java now while taking C++, you will see the similarities at a later time. Java comes with class libraries. Basically, there are a lot of libraries or uh, modules that are already created by the founders of Java, or what you will find in Java Standard Edition. So we don't have to reinvent the wheel. If you need to add two numbers, the addition is already implemented. If you want to do a square root, it is already implemented. If you want to do some trigonometry functions, it's already implemented. So a lot of things that we traditionally do, not only from a mathematical or computer science standpoint, but even from a enterprise application standpoint, a lot of things are built in Java libraries or called Java class libraries. You will get to know them as we progress through this semester. What is a typical life cycle for a Java project, Java program? You write the code, you will write it into an editor. You can use a very basic text editor. You can also actually use the Java online editor. There are a bunch of Java online editor where you don't actually need anything. You just write the code and done. Like this, this is it. So you can do this, you can save your file. You actually don't need Eclipse, but Eclipse is one of those software that is used by many, many people, and therefore I kind of encourage students to uh, download the Eclipse software. But you can use one of the many Java online editors that are out there and actually use. I can show you another one right here uh, as well. You can see another one here. This is just an example, so as to give your mind going. Here there is a java.lang.math. This is a class that has been imported, the library concept that I was telling you about earlier. Here is the other example of how you can write, and you have a class. You can call it test, and or Rex tester, and you can have a method which will generate hello world. You can run it and you will see the output show up. So these are very simple online editors that you can use and write your code online. This is very simple. However, I don't want to confuse anybody by saying that Eclipse is not good. Eclipse is equally important. It gives you confidence in making sure your code is running fine. So you will write the code, it will save onto your secondary storage. Remember, we talked about it, it's the hard disk. Subsequently, you will compile your code. As you are saving the code in Eclipse, it is automatically compiling. That means if you find a problem, it will show you the red squiggly line. So compilation is happening almost instantaneously in software like Eclipse. Then you will be loading the program into memory. Basically what I mentioned earlier, anything you run, whether it is a YouTube video or this video presentation or a website or a Java program, everything that you run is actually loaded from the secondary storage into the primary memory or random access memory. So it will load into the memory. It will verify the byte code, which is nothing but the zeros and ones created for the code that you have written, and then it will execute. So if if the program that you written does something, it will show you or what have you. So this is how the Java project or a program runs from the creation until the execution of it. The textbook actually comes with some sample codes you can download and look at it. There is one code which is called Painter, and you can see how you can run it, you can engage with it, you can um, play with it, make some drawings, and exit out. This is something that the textbook publisher has provided, so feel free to use it. Just jumping on to the internet and the World Wide Web. Internet is no stranger to anybody. We are living in the age of internet. There is some background provided to you about what is internet, what is World Wide Web, and some of the mashup. One of the concept that the textbook explains about mashup, meaning how Google Maps can be mashed up for along with perhaps Craigslist to match where the things are being sold, or Zillow, which gives you the listing of the uh, homes for sale on a Google Maps, so you can know where the locations are. So these are some examples here. You may have heard about Internet of Things. If not, Internet of Things is basically um, the things or the devices that are connected to internet. We have Fitbit, we have Apple Watch, and we have the Alexas and the Echo and Google Home and all the Xboxes and PSPs and PS4 and all that stuff. They're all connected to internet. So we are not talking just about two computers connected to each other on in an online environment. You can have all these devices that are connected to one another. That's the IoT or Internet of Things. Um, Software technologies, you have agile software development, refactoring, design patterns, LAMP, software as a service, SaaS or PaaS, platform as a service, cloud computing, and software development kit. So these are some of the concepts I want you to go through so you understand what some of the basic things that you may come across in your conversation with your peers or somebody who is in computer science or MIS degree plan. Um, when you're writing the code, the first time that you execute is called the alpha release, and then you do a beta release, whereby you are asking some external people to test your application. You have release candidates, which are feature is complete. Then you have your final release, and then you continuously evolve with beta releases subsequently. If you have questions as you're going through the course, you can certainly ask me. However, there are these other websites listed here you can use to get your questions answered as well in an online environment. There are some questions at the end of this chapter, and going back to our week 2, this is where I would like to end my video. I hope this video is helpful and gives you a background about the computer, the internet, the Java, and some other things that you will be learning in the coming weeks. Thank you so much. Have a wonderful day. I will be making a link to this video right here in the week 2, so you can see assignment aid just like chapter 3 has, and you will see right here which will allow you to go through this PowerPoint, this video, excuse me. Have a wonderful day. If you have any questions, please reach out.